Assalamualaikum warahmatullahi wabarakatuh. So this is last chapter for this code. That is chapter 7. That is basic chromatography. Okay, before we start about chromatography, please watch this video. Okay, this video shows about the chromatography. So as an introduction, so chromatography is a technique for separating mixtures into their components based on differences in the rates at which they are carried through a stationary phase by mobile phase, gas or liquid. So from here you can see that chromatography is a technique for separation. Teknik untuk kita separatekan mixture. So for example kita ada mixture. Mixture ni kita tahu kan dia adalah combination daripada a few substance, a few molecule. So kita nak separatekan dia daripada molekul-molekul tu. So ni chromatography adalah teknik untuk separating the mixture. So dia guna apa? Dia guna stationary phase and mobile phase. So there is a stationary phase and mobile phase. So dia adalah berdasarkan perbezaan antara rates yang lalu pada stationary phase dengan menggunakan mobile phase. So nanti kita tengok what is the definition of the stationary phase and what is the definition for the mobile phase. Okay. So why we need separation? Okay, first we want to analyze. So we want to analyze whether the mixture is this kind of the substance. So we can analyze the mixture, or we can identify. Thirdly, we can purify the mixture. So from this mixture, we can purify to become the substance. Okay, the molecule, type of molecule, jenis molekul yang ada lah dalam mixture tu. So kita nak purify, kita nak bersihkan dia, kita nak jadikan dia pure. Or we can quantify the mixture. So kita nak kira mixture tu berapa dia punya quantity. So this is why we need a separation. We want to analyze, we want to identify, we want to purify, or we want to quantify the mixture. So this is the principle for the chromatography. So sample is dissolved in a solvent and washed through a stationary phase by a mobile phase called eluent. So eluent, we have the eluent. So eluent is when we have the sample, we dissolve in a solvent and it washed through a stationary phase. Kita melalui stationary phase. So maksudnya eluent ni yang substance yang kita dissolve dalam solvent, kita lalu dalam stationary phase. Tapi kita gunakan mobile phase. Okay, so this one is a eluent. The competition between the sample molecule absorbed by the stationary phase and dissolved by the eluent results in separation. So macam mana berlaku separation tu? Okay, because of the competition between the sample molecule. So contohnya kita ada mixture, dia adalah combination daripada molekul-molekul yang ada. Contohnya saya ada satu mixture. Mixture ni adalah saya lakukan dari satu reaction. Dia adalah mixture daripada benzaldehyde, styrene, styrene oxide. Okay, so saya nak separatekan antara benzaldehyde, styrene dengan styrene oxide tu. Okay, so saya akan buat chromatography. So dia akan lalu stationary phase dengan menggunakan mobile phase. So ada competition antara molekul-molekul tu. So dia boleh separate. Substances that are more soluble in the eluent and less absorbed by the stationary phase move faster through the apparatus. So kita ingat kita ada mixture, and mixture tu dia akan larut dalam eluent. So kita akan lalu dalam stationary phase. So stationary phase ni dia akan absorb dia akan absorb substance tu. So substance yang yang kurang soluble, yang kurang larut dalam eluent tu, dia akan absorb dahulu. Dia akan absorb dahulu oleh stationary phase. So yang lebih soluble, dia akan kurang absorb oleh stationary phase. So dia akan melalui apparatus. So kita tengok dulu ya. Kita tengok lepas ni. Speed of the substance pass through depends on the nature of the stationary phase and the eluent. So, kelajuan dia lalu dekat apparatus tu adalah bergantung kepada stationary phase tu sendiri dan juga eluent. So, components in the mixture spread out as the mobile phase move through the stationary phase. So, ingat So, mobile phase ni akan lalu. Mobile phase ni termasuk mixture tu lah. So, dia akan lalu stationary phase. Okay. So, dia akan separate. So, kita akan tengok gambar lah selepas ni macam mana separation tu berlaku. Okay, this is the example for the chromatography. So, this is the stationary phase, and then we have the mixture. So, we have the mixture and mobile phase. So, mobile phase ni dia akan gerakkan mixture melalui stationary phase. So, bila dia melalui stationary phase ni, mixture ni akan berlaku separation. Dan dia berlaku separation bergantung kepada ketelarutan mixture tu dalam eluent. Ataupun bagaimana stationary phase absorb mixture tu, komponen tu. So, maksudnya kat sini, bila mixture yang kurang soluble dan mudah absorb oleh stationary phase akan separate dahulu. So, yang lebih soluble dalam mobile phase, dalam eluent tu dan kurang absorb oleh stationary phase, dia akan lalu lebih laju. So, berlakulah separation seperti ini. So, maksudnya yang lebih atas tu maksudnya dia adalah lebih soluble dalam eluent dan juga dia kurang absorb oleh stationary phase. So, ni berlaku separation. Okay. So, kita dampatlah kat sini after the separation berlaku molekul-molekul atau komponen-komponen tu telah pun diseparatekan, telah diasing-asingkan seperti itu. So, this is the definition of the mobile phase and stationary phase. So, mobile phase is eluent. Okay, benda yang kita larutkan, the component or the substance yang kita larutkan kan dalam eluent ataupun kita larutkan dalam mobile phase. So, mobile phase where molecules can move, liquid or gas. Dia bergerak. Mobile phase ni dia bergerak melalui stationary phase. So, medium which can mixture to be separated move in a particular direction. Dia akan bergerak melalui stationary phase, melalui satu direction. So, dia akan separate. Okay. Carries analyte through the chromatography apparatus. So, mobile phase ni dia bawa analyte melalui apparatus chromatography tu. So, itu adalah mobile phase or eluent. So, what is the stationary phase? So, molecule cannot move. Solid or liquid held in solid. So, stationary phase, the molecules cannot move. Stationary phase tak bergerak. Dia sama ada solid, liquid yang dipegang oleh solid. So, maksudnya tak boleh bergerak lah sebab solid dan liquid ni telah dipegang oleh solid yang lain. So, stationary phase is not move. So, bed or support substances that are fixed. So, dia fixed sebab ada support daripada solid yang lain. So, the phase where the phase which the mobile phase travel through. Dia adalah stationary phase ni adalah satu keadaan yang fixed tapi dia akan dilalui oleh mobile phase. So, mobile phase yang akan bergerak melalui stationary phase. Okay, now you must know about the elution. So, elution is a process where the solids are washed through a stationary phase by the movement of mobile phase. So, pergerakan mobile phase with mixture bergerak melalui stationary phase ni kita panggil dia elution. Okay, so dia akan bergerak melalui stationary phase. So, this is the elution. So, eluate. So, eluate is a mobile phase leaving the column. Dia keluar daripada column, mobile phase yang keluar daripada column tu, we call it as eluate. Next, you must know about the retention time. So, retention time is a time taken for a component in a sample to pass through the column Column ni stationary phase tu. So, masa yang diambil untuk komponen dalam mixture sampel tu untuk lalu stationary phase, untuk lalu satu column. Okay, tu kita panggil dia retention time. So, next is retention factor, RF value. Is the distance travel by the component divided by the distance travel by the solvent. So ingat mixture tu akan melalui column. So dia punya jarak dia lalu tu itu adalah retention factor, iaitu distance travel by the compound divide with the distance travel by the solvent, the eluent. And chromatogram. Chromatogram is a visual output of the chromatograph. So this is the example of the chromatogram. So kita kata dia visual output. So different peaks or pattern on the chromatogram correspond to a different components of the separated mixture. So setiap peaks ni dalam chromatogram ataupun pattern dalam chromatogram ni adalah menggambarkan komponen untuk mixture tu. Yang kita dah separate lah, komponen yang kita dah separate, substance yang kita dah separate daripada mixture. For example, yang ini ada dua peak ni, maksudnya kita dalam satu mixture tu kita ada dua components. Okay, so this is the chromatogram. So this is the applications for chromatography. First, for the pharmaceutical company. For example, to determine the amount of chemical in new product. Or in hospital, we use to detect blood or alcohol level. So we use chromatography. Or law enforcement, if we want to compare a sample found at a crime scene with sample from suspect. For the environmental agency, for example, to determine the level of pollutants in the water supply, or for the manufacturing plant, to purify a chemical needed to make a product. So, maksudnya kat sini application ni dah meluas. Chromatography memang digunakan untuk pelbagai applications. Okay, next we go to types of chromatography. Okay, types of chromatography yang kita nak cerita ni adalah berdasarkan analyte interaction with stationary phase. Okay, types of chromatography are based on analyte interaction with stationary phase. Okay, we have 4 types of chromatography based on analyte interaction with stationary phase. For the first one is adsorption. Second, partition. Third is ion exchange, and lastly, pore penetration. Now we go to adsorption. Okay, ini analyte interaction dengan stationary phase. Okay, so absorption. So bagaimana analyte tu interact dengan stationary phase by the absorption. So also known as liquid solid chromatography. Okay, absorption. This one is we know that as liquid and solid chromatography. Analyte is separated based on different degree of adsorption. So dia separate berdasarkan degree of adsorption on a solid stationary phase. So stationary phase is a solid or polar packing on which sample components are absorbed. For the stationary phase, we use the solid polar. Okay, solid polar packing. And mobile phase may be liquid or a gas. Okay, so stationary phase tu mestilah solid. Mobile phase sama ada liquid ataupun gas. So that's why we call it as liquid solid chromatography. Okay, so ataupun it can be gas solid chromatography. So tapi stationary phase tu wajib adalah solid. So if liquid solid chromatography, the short form is LSC. But if we use gas solid chromatography, we use GSC. So the separation based on the degree, the different degree of intermolecular interaction, some component of the mixture will be more attracted or absorbed to the stationary phase. Okay, so dia adalah berdasarkan degree intermolecular attraction. Okay, ada setengah komponen ni dia lebih attract atau lebih absorb oleh stationary phase. Ada yang setengah komponen dia kurang absorb oleh stationary phase. So that's why it based on the absorption, the degree of absorption. Okay, for liquid solid chromatography or gas solid chromatography, that is for the absorption chromatography, stationary should be solid phase. Okay, dia mesti solid. But for the mobile phase, it can be liquid or solid. Kalau liquid, liquid gas chromatography. Kalau gas, dia adalah gas solid chromatography. So mobile phase, it can be liquid or gas. Kan solid liquid or gas. So this is solid molecule. Okay, solid molecule, and solid absorb on the surface of stationary phase. So solid ni it can be liquid or it can be solid. It can be liquid or it can be gas. It can absorb to the stationary phase. Okay, so dia bergantung kepada darjah dia absorb. So ada yang setengah yang akan mudah absorb, ada setengah yang susah absorb. Okay. Okay, this is the example for the absorption chromatography. Okay, absorption chromatography. For the first one is thin layer chromatography. This one is TLC, thin layer chromatography. So thin layer chromatography ni macam ni lah ibaratnya. Kita ada stationary phase, that is plane. Kita ada satu plane. Okay, this is a plane is a stationary phase, and then a solid supported to an inert plate. So kat sini ada solid. Kita ada plate kat sini. Okay, kat plate ni ada solid. Okay, itu adalah stationary phase. Okay, kita ada satu plate. Dekat permukaan plate ni ada apa? Ada molekul lah, ada something, ada solid yang kita attach pada permukaan plate tu. Yang itu adalah solid. Okay. And mobile phase should be the liquid solvent. So this one we call it as thin layer chromatography. And then we have the column chromatography. Okay, this one is a column chromatography. Column chromatography, kita ada satu column. Okay, satu column, satu bahagian yang panjang. Okay, column. And the stationary phase is a silica gel. So dekat column tu kita letak silica gel. That is a solid. And then the mobile phase should be solvent, liquid. Okay, bergantunglah types of solvent. Okay, so mobile phase is solvent or liquid. And then gas solid chromatography. Okay, kalau gas solid chromatography, the stationary phase should be solid. Okay, and the mobile phase is a gas. Okay, from here you can see that, from this example you can see that the stationary phase should be a solid. Semua kat sini stationary phase semuanya adalah solid. But the mobile phase, it can be liquid or it can be gas. So that's why for the absorption chromatography, we call it as solid liquid chromatography or solid gas chromatography. Gas solid chromatography or liquid solid chromatography. Terbalik tadi, liquid solid chromatography or gas solid chromatography. Okay, for the second types of the chromatography is partition chromatography. Okay, partition chromatography. So it is also known as liquid chromatography. So kat sini the liquid. Yang tadi liquid solid kan? Ataupun gas solid. This one is liquid chromatography. So stationary phase is a liquid supported on an inert solid or surface of packing particles. So we have the solid. Okay, and this solid is surface packing particle. Ada particle kat solid tu. And then there is a liquid. Yang liquid yang pegang pada solid tu. Solid yang pegang liquid. The solid dia pegang liquid. Okay, so that's why stationary phase is a liquid supported on an inert liquid. And mobile phase may be liquid. Mobile phase mesti liquid. Ataupun it can be gas. So that's why for the partition chromatography is liquid chromatography or gas liquid chromatography. Okay, separation is based on solid partitioning between two immersible liquid phases or relative solubility. So maksudnya kat sini separation dia adalah bergantung kepada solubility. Okay, immiscible liquid phase, sama ada dia larut ataupun dia tak dalam liquid yang pada permukaan stationary phase tu ataupun tak larut. Okay, dia bergantung pada keterlarutan dalam liquid pada stationary phase tu. Liquid yang ni lah, liquid supported pada stationary phase. Okay, this is an example for the partition chromatography. Okay, so ingat kita ada solid, solid, and then kita ada liquid yang pegang liquid pada permukaan solid chromatography tu, pada solid tu. So, yang liquid yang pegang pada solid ni, kita katakan dia adalah stationary phase. That is a liquid supported on solid. Okay, so this liquid is a stationary phase because this liquid support pada permukaan solid. And then this is mobile phase. The mobile phase is a liquid. Okay, so solid dissolve in a liquid coated on surface. So kalau kita tengok sini, yang ini, yang titik-titik ni, yang dot-dot ni adalah solid. Yang komponen tu. So komponen tu akan absorb, akan dissolve dalam liquid dalam stationary phase. Okay, so dia akan separate based on ketelarutan dia dalam stationary phase ni. So sama ada kalau dia mudah larut, dia akan separate kepada mudah larut dan kurang larut lah. Itu adalah partition chromatography. So, two main types of partition chromatography based on a type of stationary phase. Okay, partition chromatography ada dua jenis. Okay, ada dua jenis partition chromatography dan dia bergantung kepada jenis stationary phase. For the first one, okay, first types of the partition chromatography is normal phase liquid chromatography. Second type is reverse phase liquid chromatography. So we go one by one. For the first one is normal phase chromatography. Okay, so for normal phase chromatography, the stationary phase is polar stationary phase. Okay, polar. So sebab itulah dia mudah absorb sebab dia ada satu jenis fasa tu dia adalah polar, satu lagi tak polar. So that's why dia boleh bergantung kepada the solubility. So, for this normal phase chromatography, the stationary phase is a polar stationary phase. For example, methanol on silica gel. Okay. And for the mobile phase, it should be non-polar. Kalau stationary phase polar, mobile phase should be non-polar. Okay. Kalau normal phase, stationary phase mesti polar. And separation is favors retention of polar compounds and elution of non-polar compounds. So, dia punya bergantung kepada ketelarutan dia dalam polar compound. Okay, daripada non-polar compound. So, non-polar compound, so dia boleh masuk ke komponen boleh masuk kepada ke polar compound. For the reverse phase chromatography, reverse phase chromatography, the stationary phase should be non-polar stationary phase. Okay, non-polar stationary phase. And the mobile phase is a polar mobile phase. Polar mobile phase. Terbalik dengan normal phase chromatography ni. So separation, non-polar solid are retained more and polar solids more readily eluted. So, non-polar solid ni akan retain lebih dalam polar solids. Okay, this is an example for the partition chromatography. For the first one is HPLC, High Performance Liquid Chromatography. So, this is High Performance Liquid Chromatography. And then paper chromatography. So, this is paper chromatography. And lastly is gas liquid chromatography, GGC. Okay, this is gas liquid chromatography. Okay, third types of chromatography is ion exchange. So, ion exchange resin as stationary phase. So, stationary phase, ion exchange resin. Used to separate charged species. This one for the charged species. So, mechanism separation is based on ion exchange equilibrium. Okay, last types of the chromatography, size exclusion. Solvated molecules are separated based on their size by their ability to penetrate a sieve-like structure, a stationary phase. So, size exclusion dia bergantung pada size. Okay. Tapi, sebab dia ada seperti sieve-like structure. So, sieve-like structure is a stationary phase. Okay, tadi awak belajar adalah types of chromatography based on analyte interaction with stationary phase. These types of chromatography, okay, jenis type of chromatography yang lepas ini adalah based on separation technique, okay, whether it is column or planar, okay. So, types of chromatography based on separation technique, column or planar. Okay, for the first one, column chromatography. So, use glass tube with tap and a filter, a glass frit or glass wool plug as to prevent the loss of the stationary phase at the bottom. Okay, there is a glass tube with tap and a filter. So mechanism we use, or type of force is we use gravity. Okay, because there is a filter. So two methods are generally used to prepare a column. Okay, dry method and wet method. Okay, this is column chromatography. Okay, this is the differences between the dry method and wet method. Okay, so dry column is filled with dry stationary phase followed by the addition of mobile phase, which is flushed through the column until it is completely wet. Okay, so kita ada column. Okay, the stationary phase is a dry powder. Okay, and then we have the mobile phase. We add the mobile phase until the dry powder is wet. And wet method is column is filled with slurry of stationary phase powder and eluent. Okay, column tu kita dah letak slurry of stationary phase powder and the eluent. Okay, dia dah basah lah. A solution of organic material is pipette on top of the stationary phase. Okay. This layer is usually topped with a small layer of sand or with cotton of glass wool to protect the shape of the organic layer from the velocity of newly added eluent. And eluent is slowly passed through the column to advance the organic matter. So kita tambah solution of organic material masuk ke dalam top of the stationary phase. So dia akan lalulah dekat dalam column tu. So the individual components are retained by the stationary phase differently and separate from each other while they are running at different speeds through the column with the eluent. So dia akan jatuh ni berdasarkan dia punya kelajuan. Ni dia punya proses separation dia. Okay. Dia akan lalu satu column. And okay, cara dia yang pertama ni, there is a solvent here. We put the solvent and mixture of compounds A, B plus C. Okay, so dia akan lalu kat sini. And this is the absorbent, the stationary phase. Okay, kita letak stationary phase dekat sini. And this is the glass wool. Kita tutup lah awal-awal. Okay, then, so bila kita letak, kita biarkan dia pada satu masa, so dia akan berlaku separation. For example, dia akan separate A dahulu. Ni B plus C. Okay, so dia akan lalu lagi. And then after kita biarkan dia lagi, so dia akan berlaku separation lagi. So dia akan lalu pada stationary phase ni. Okay, so akan berlaku separation antara A, B plus C dan C. So kita nampaklah berlaku separation pada kolom chromatography tu. Okay, ni antara contoh juga. Okay, so ni kita letak sampel. Okay, ni kita letak sampel yang kali hijau ni. Ni adalah stationary phase. And then we add mobile phase. Okay, kita letak mobile phase tu ke atas. So mobile phase tu akan bergerak lah, akan menolak masuk sampel tu. So kita akan masuk akan berlaku sampel akan berlaku sampel separation. Kalau kita nampak dekat sini, dia start separate. Okay, so dah berlaku start separate. And then kat sini kita tengoklah yang orange ni adalah dia lebih interact lebih kuat. So that's why dia tertinggal dahulu. And then yang cepat interact, yang kurang interact dengan stationary phase, dia akan bergerak lebih ke bawah, lebih laju. So lepas tu kita boleh keluarkanlah ni, kita boleh keluarkanlah yang eluted, yang color hijau ni. Then kita boleh keluarkan yang color orange tu. Okay, stationary phase for the column chromatography, it should be solid and finely ground powder. Solid and finely ground powder. This is a microporous to increase the surface area. For example, silica gel, alumina and cellulose powder. But for the mobile phase, it's a pure solvent or mixture of different solvent. So faster flow rates can be achieved by using a pump or compressed gas, air, nitrogen or argon to push the solvent through the column. Kita kadang-kadang kita letak bawah compressed gas supaya dia lalu kolom tu lebih cepat. Okay. Okay, this is the advantages and disadvantages of the column chromatography. Okay, advantages for the column chromatography. First, low cost and disposability of the stationary fees. So the low cost can be scaled to the project at hand. Determine the number of components of a mixture. So it can determine the number of components of the mixture. And separate and purify substantial quantities of those components for subsequent analysis. So we want to separate or purify the quantities of the component. But disadvantages of the column chromatography, okay, take time to prepare and use. Dia ambil masa untuk prepare dan guna. It requires some technical skill and manual dexterity. It requires constant attention while the experiment is being performed. Okay, for the second type of the chromatography, okay, based on the separation technique, is planar chromatography. So, planar chromatography can be divided into two types of planar chromatography. For the first one is paper chromatography, and the second one is thin layer chromatography. For the paper chromatography, so paper chromatography is a sheet or a narrow strip of paper serve as the stationary phase. So we have the sheet or narrow strip of paper. So we use a paper as a stationary phase. For the thin layer chromatography, okay, thin layer chromatography is a thin film of a stationary phase of solid particles bound together for mechanical strength with a binder such as calcium sulfate coated on a glass plate or plastic or metal sheet. So we have the glass plate or plastic or metal sheet, and there is a thin film, okay, of the stationary phase of the solid particle. Okay, we bound on the glass plate or plastic or metal sheet. Kita coated pada glass plate, plastik atau metal sheet. Okay, kita ada stationary phase, kita coated pada permukaan permukaan yang ni lah, glass plate, plastik ataupun metal sheet. Okay, now we go one by one. For the first one is paper chromatography. So for paper chromatography, the mobile phase is an organic solvent. So organic solvent is a mixture of ethanol and water. For the stationary phase is water trapped in the paper strip. Okay, water paper trapped in the paper strip. So paper strip is from the cellulose fibers made up of hydroxyl groups. Okay, so paper strip tu sebenarnya diperbuat daripada cellulose fibers, and these cellulose fibers have the hydroxyl group. Sebab dia dekat cellulose fiber tu ada hydroxyl group, air boleh absorb pada hydroxyl group. Sebab dia boleh bentuk hydrogen bonding. So air boleh attract pada hydroxyl group pada cellulose fiber. Okay. So the filter paper is used because of the paper is made up of cellulose fibers. So we use the filter paper because this filter paper made up from the cellulose fibers which contain trapped water molecules. And the trapped water act as stationary phase and the filter paper itself is the support. Okay, trapped water adalah stationary phase dan filter yang kertas tu adalah dia punya support. Here, SP stationary phase is a liquid. Okay, so stationary phase is a liquid. So advantages, cheap. Okay, cheap, murah sebab we use only the filter paper. Fast, sensitive and wide use. Disadvantages, reproducibility of the result is low and cannot withstand the corrosive chemicals. Reproducibility of the result is low ni maksudnya mungkin result pertama kita dapat hasil macam ni. Result kedua kita tak akan dapat, mungkin susah nak dapat result seperti result yang pertama. Dia mungkin dapat result yang berbeza-beza. So yang dia kata reproducibility, untuk dapatkan hasil result tu adalah rendah. Okay, and cannot withstand with the corrosive chemical. So kalau corrosive chemical tu susahlah sebab kita hanya guna filter paper. The component to be separated are partitioned between the stationary phase, that is water absorbed on the paper, and the mobile phase, okay, the solvent. If a component is more soluble in the mobile phase, that component will carry it further up on the paper and will be separated from the other components. So maksudnya kat sini separation adalah bergantung kepada solubility. So kalau komponen tu lebih soluble dalam mobile phase, dia akan lebih bergerak lebih jauh ke atas paper tu. Bergerakkan dia lebih tinggi, lebih banyak. Sebab dia lebih larut dalam mobile phase. So separation tu adalah bergantung kepada komponen tu, kepada solubility of the component dalam mobile phase. Okay, sample preparation for the paper chromatography. A sample is dissolved in a volatile solvent. The sample is spotted using a capillary tube on a line previously drawn on one end of the paper chromatography. So, kat paper chromatography tu, kita letak satu line. Okay. So, satu line. And then sample tu kita letak pada atas line tu. Atas line pada paper chromatography. And the spot should be dried first before the second time as to make sure that the diameter of the spot is less than 5 mm. So, kita keringkan dahulu. Okay. And the diameter spot is less than 5 mm. Chromatograph is done by dipping one end of the mobile phase. So, we dipping one end of the mobile phase. So, kita letak paper chromatography tu, paper yang kita dah letak dengan spot, kita masukkan dalam mobile phase. Okay. All spot, okay, development of chromatograph, all spot are allowed to dry first before it is dipped into the development of solvent, the mobile phase. So, spot tu kita kena keringkan dahulu sebelum kita masukkan dalam mobile phase, okay, the solvent. So, the development tank should be closed so that the development chamber is saturated with the development solvent, okay. So, tank should be closed. This is to make sure that the spot move upward smoothly by capillary action without interruption. So, kita nak pastikan dia naik ke atas smoothly. Okay, kita tak nak ada apa-apa interruption. So, that's why we need to close the tank. And the solvent will carry the various spot upwards at different rate until the solvent front is about 3 to 4, okay, 3/4 of the paper chromatography. PC means that paper chromatography. So, kita biarkan dia naik ke atas sampai dia lebih kurang 3/4 daripada paper chromatography tu. Okay, ni contoh dia kan. Okay, ni contohnya. So, kita letak satu line kat sini. So, kita letak satu spot ni. Okay, kita letak satu spot dekat atas line. And then, kita letakkan dia dalam mobile phase dekat sini. Mobile phase kat bawah ni. Okay. Okay, lastly is identification of retention factor, RF. So, we can determine the RF, the retention factor. So, RF is equal to height of spot divided by height of solvent. Okay, so this is height of the spot. Ni spot yang kita nampak dengan tinggi solvent tu. So, solvent tu kita nampak lah dia akan bergerak tinggi mobile phase tu. So, mobile phase ni akan bergerak. So, kita akan nampak lah spot-spot kat sini. Suppose tinggi spot tu kita bahagikan dengan tinggi solvent. So, RF or sample is identified by comparing to its standard as it has the same RF value. Okay. So, kita kena compare dengan standard yang sama RF value. Okay. So, this is the origin line. Okay. Where the spot. Okay. Where the kita letak spot tu. Okay. Di mana kita letak spot tu, and then bila kita masukkan dalam mobile phase, dia akan naik. So, spot yang berlaku tu, okay, ini kita kata tinggi spot. Okay, dan bahagikan dengan tinggi solvent. So, retention factor, okay, RF tadi adalah distance moved by substance divided by distance moved by eluent, ataupun kita kata tinggi spot tu bahagikan tinggi solvent. Okay, seperti yang tadi tu lah. So, values below 0.1 is considered poor. So, the spot are too close to origin. So, kalau kita dapat nilai dia 0.1, kita katakan dia spot tu sangat dekat dengan origin. So, kita kata spot tu adalah poor. Okay, nilai tu adalah tak bagus lah. If value is 0.1 to 0.8, so good, and any other spot impurities or other active are resolved from each other. Okay, value 0.1 hingga 0.8 adalah value yang kita nak. Okay. Okay, above 0.8 is poor. Spot may be too broad or distorted. So, tapi kalau nilai tu lebih kepada 0.8, kita kata result tu pun tak elok lah. Poor result. Because spots may be too broad or distorted. Solvent move through the paper drawn by capillary action. So solid move as spot with a rate depending upon how much time they spend in the stationary phase, determined by the partition coefficient, that is RF value. So kat sini kita tengok bila kita masukkan dalam mobile phase, so kita akan tengok dia akan bergerak. Bergerak dalam paper tu, bergerak melalui paper tu. So, spot tu akan melalui paper tu bergantung kepada kadar dia berada pada stationary phase. Okay. So, kita akan determine dia punya RF value. Okay, this is the example of the paper chromatography. Ni secara yang real lah. Kita mesti masukkan dalam tank. Okay, we put the paper chromatography in a tank. Okay. And then, the solvent here is a mobile phase. And then we put dot here. We put spot here, okay. So, the spot will move through the paper chromatography, okay. So, from here you can see that there is a spot, okay. Spot yang kita dah separate lah. Ni yang berlaku separation lah tadi. Ni daripada black ink. Okay, ingat kalau black ink, kalau contoh kita guna nak separate black ink tu, okay, color hitam, ink yang color hitam, kita nak separatekan dia. So, kita akan spread, kita akan biarkan dia lalu je, okay. So, mobile phase ni dia yang akan bawa melalui paper chromatography. So, akan berlakulah separation daripada black ink tu. Akan jadi biru, merah, kuning. Akan berlaku paper, pergerakan pada permukaan paper chromatography tu. So, kalau kat sini awak akan nampak lah. So, bila kita masukkan dalam eluent, kita masukkan dalam mobile phase, so akan berlaku pergerakan spot tu, titik spot tu. So, dia akan berlaku separation. So, from the black ink to another color. Ni black ink, dia akan jadi biru, hijau, merah macam tu. Okay. So, kat sini adalah distance the spot travel. Okay. Nak cari RF value, the distance the spot travel divide by maximum distance eluent travel. Ni sampai mana eluent tu bergerak. So, kat sini kan spot-spot tu. So, eluent tu bergerak sampai sini kan. Sampai titik ni. Sampai garisan ni. So, kita kena tengoklah dia move sampailah garisan ni. Okay, yang tu adalah maximum distance eluent travel. So, nak calculate RF value, distance the spot travel divided by maximum distance of the eluent travel. Okay, ni juga adalah antara contoh paper chromatography ni. Kita masukkan dalam, waktu kita nak buat ni, kita masukkan dalam bekas, mesti yang bertutup. So, kita letakkan spot. So, kita nampaklah daripada spot tu dia akan bergerak. So, dia akan berlaku separation. So, daripada spot kali hitam ni akan berlaku separation pelbagai warna kat sini. So, sampai sini lah. So, kat sini kita boleh tengok pergerakan solvent tu. Okay, this is an example for the paper chromatography. Sama juga. Okay, so beaker with stationary and mobile phase, stationary phase and mobile phase. So stationary phase is chromatography paper, the filter paper. Again, we put it in beaker. So there is a mobile phase, elution of the ammonia, butanol and water. We put in the beaker, okay, inside the beaker. And then we put the paper, okay. And then we draw a line here, okay. We draw a starting line, okay. This is the starting line. Ink spot are centered and evenly spaced on the starting line. Kita buat space lah. Notice that the line and ink dot must be above the liquid level. Mesti atas liquid level. Jangan letak pada permukaan liquid tu. Kalau kita letak permukaan liquid tu terus dia terus tak jadi kan. Tapi kita letak di atas permukaan spot tu. Above the liquid level. In the beaker, when the paper is placed in contact with the mobile phase. Okay, kena pastikan paper tu kena dekat paper tu. Tapi kena mesti wajib di atas line. Okay. Kena atas spot. Spot ke atas. Kena bawah spot. If it were below the liquid level, the ink would wash out into the liquid. Tu dah saya kata. Dia tak jadi. Sebab apa? Ink tu dia dah cuci pula. Ink tu dah cuci pula. Kalau kita letak liquid tu pada permukaan ink tu, pada spot tu. Nanti dah wash out. So macam mana kita nak menengok separation kan? So kita kena letak spot tu, kena letak atas level air tu. Ni liquid level. Spot kena letak kat atas. Okay, so this is the finish line. So when solvent from reach this line, remove the paper from the mobile face. Kena sampai line ni. Okay, biasanya kita guna adalah 3/4 lah daripada line. Okay, try this question. Okay, calculate the RF value. So you can calculate the RF value for this question. Okay, this is for the second types of planar chromatography. That is thin layer chromatography. Okay, the short form is TLC, thin layer chromatography. So for this thin layer chromatography, the mobile phase is a liquid solvent, and the stationary phase is a solid absorbent. So from here you can see that it is absorbent. So we have the glass plate covered with a thin layer of alumina or silica gel. So this alumina or silica gel is an adsorbent. In this technique, a small quantity of solution of mixture to be analyzed is deposited as a small spot on a TLC plate which consists of a thin layer of adsorbent, this silica gel or alumina, coated on a glass plate or plastic sheet. Kalau kita tengok pernyataan ni, kita nampak dia TLC ni lebih kurang dengan paper chromatography. Okay, lebih kurang. Bezanya, for paper chromatography, we use paper. Okay, we use paper. But for the TLC, thin layer chromatography, we use glass plate or plastic sheet, but we cover it with the adsorbent. The adsorbent is a silica gel or alumina. Okay, beza dia hanya tu saja. Tapi cara dia, teknik dia adalah sama. Kita still letak satu spot pada line. Kita buat satu line and then kita letak spot. And then kita tengok dia pergerakan spot tu after kita letak dalam mobile phase. Okay, the liquid solvent. So for more information, you can watch this YouTube video. Prepare a mixing the adsorbents such as silica gel with a small amount of inert binder, calcium sulfate and water. So we have the adsorbent. Such as silica gel with calcium sulfate and binder. So this mixture is spread as a thick slurry on a reactive carrier sheet, usually glass, thick aluminium foil or plastic. So lepas kita buat absorbent tu, okay, kita spreadkan dia. Kita spread macam kita buat roti spread tu. Kita spreadkan dia atas permukaan glass atau plastik ataupun aluminium foil. Okay, untuk kita jadikan dia sebagai solid. Okay, thin layer. This thin layer boleh kita masukkan dalam mobile phase. So the resulting plate is dried and activated by heating in an oven for 30 minutes at 110 degrees Celsius. Okay, after kita spreadkan dia, jangan lupa untuk kita masukkan dalam oven. Tujuan kita masukkan dalam oven sebab tadi kita dah mix absorbent tadi dengan air, dengan calcium sulfate. So dia basah. So kita kena pastikan dia kering sebelum kita gunakan dia, kita masuk dalam mobile phase. So kita kena keringkan dia dalam oven about 30 minutes at 110 degrees Celsius. And the thickness of an adsorbent layer is typically around 0.1 to 0.25 mm for analytical purposes and around 0.5 to 2 mm for preparative TLC. So ni dia ada punya thickness dia, ketebalan dia. Okay, this is TLC. Okay, for the first figure, it shows the TLC plate. Ni adalah TLC plate. And the second figure, it shows the TLC experiment, TLC chromatography. So kat sini kita nampak lah yang putih ni bukan paper chromatography ya. Yang putih ni adalah plastik ataupun glass. Okay, kalau seperti ini saya rasa ini adalah glass. Dia covered dengan absorbent. Okay, and then baru dia masukkan dalam mobile phase. So, lepas saja masukkan dalam mobile phase, after a few seconds, after a few times, kita akan nampak ada pergerakan lah. Dia akan berlaku separation. Adsorbent of TLC. Okay, ni absorbent yang digunakan dalam TLC tu. Ingat TLC yang digunakan adalah solid adsorbent. So, ini adalah contoh-contoh adsorbent. For the first one is a silica gel. So, silica gel can be obtained with a small additive of calcium sulfate. because it can increase the binding to the plates and fluorescent indicator. Okay, so we use silica gel with calcium sulfate and fluorescent indicator. Second, kisilga. Kisilga. Less polar than silica gel. Less strongly absorbent. Okay, kadang-kadang orang guna kisilga instead of silica gel. And the third absorbent is alumina. So degree of absorption depend on its pH and the amount of activation. And last solid absorbent is cellulose. The spot are sharper on TLC than paper and give better separation. Available with or without binder. So kita ada 4 jenis absorbent yang boleh digunakan dalam TLC. Okay, this is principle for TLC. For the first one, sample application. The sample is spotted using capillary tube. Kita letak spot pada atas atas kita punya stationary phase. Development. A small amount of solvent is poured into a glass beaker. A strip of filter paper is put into the chamber. The paper lies on the chamber wall and reach almost to the top of the container. Dia bukan filter paper yang kita guna adalah kita punya stationary phase, the plate. And that is coated with coated dengan stationary phase, glass atau plate yang coated dengan absorbent. So dia adalah TLC tu kita menggunakan glass ataupun plate, glass ataupun plastik yang coated dengan absorbent. So the container is closed with a cover glass and left for a few minutes to let the solvent vapors ascend the filter paper and saturated the air in the chamber. So the solvent move up the plate by capillary action. So ni lah plate yang kita guna, and then this plate is covered with the stationary phase of the absorbent. Okay, and then we put spot on the line of the plate. Okay, and then kita letaklah dalam mobile phase, and then tutup. Kita kena tutup lah. And then after a few seconds, maybe after a few hours, dia akan nampak lah dia pergerakan tu lah. Mobile phase tu akan bawa spot tu naik ke atas dan berlaku separation. So different analyte in the sample travel at different rates due to differences in their attraction to the stationary phase. Okay, macam mana dia berlaku pergerakan tu? Macam mana berlaku separation tu? Separation tu berlaku disebabkan oleh perbezaan attraction. Perbezaan dia tarikan dengan stationary phase. So yang mudah tarik oleh stationary phase, dia akan yang tarikan kuat dengan stationary phase akan tertinggal dahulu. Yang kurang tarik dengan stationary phase akan bergerak naik ke atas. So the more strongly compound is absorbed. The less distant it can travel up the plate. So kalau dia kuat ikatan dia akan less distant. Dia akan travel less distant instead of yang kurang tarikan dengan stationary phase. Visualization. Spot that are fluorescent or colorless can be visualized using following method. So ada spot yang kita tak nampak dengan mata kasar. Okay, dia colorless. So kita buat visualization process. First, exposing the plate to iodine vapor. Black spot will appear and mark the spot with pencil. So use iodine vapor. Spraying the plate with 9-hydrin. Heat the plate in oven. Spot will appear. Okay. And spraying the plate with concentrated sulfuric acid and heated at 100 degrees Celsius. Black spot will appear. Or you can using fluorescent indicator TLC plate which can be visualized under UV light. Ini cara-cara kita nak dapat lihat spot after kita buat TLC. Okay, kita nampak dia akan berlaku colorless. Colorless tak nampak kan? Dengan mata kasar kita buat proses ini untuk kita dapat lihat lah. Identification retention factor RF. So RF is equal to height of spot divided by height of solvent. So RF or sample is identified by comparing to its standard as it has the same RF value. Okay, kita boleh buat comparing lah sebab kita akan dapat RF value yang sama. Okay. And this is the applications of TLC. First, for analyzing ceramide and fatty acid, detection of pesticide or insecticide in food and water, or analyzing the decomposition of fibers, or identification of medicinal plants and their constituent. So this is the example of application in TLC. Compared to paper, TLC is faster run, better separation and have choice between different absorbing. So that's why kita akan lebih prefer more on TLC as compared to paper chromatography. And this is the advantages of TLC. Okay. First, fast separation. Second, spot are more discrete. Okay, more discrete tu maksudnya dia nampak lebih bulat, lebih nampak lebih tepat lah. Dia tak akan nampak macam manjang. Dia dapat more discrete. Can withstand corrosive detection reagent without harming the absorbent. So, dia boleh bertahan dengan corrosive reagent. Corrosive reagent ni yang kuat lah dan boleh menghakis. Okay, tanpa merosakkan absorbent tu. Okay, tanpa merosakkan absorbent stationary phase tu. So, that's why we choose TLC as compared to the paper chromatography.